Hello everyone, welcome to the second week's lecture on development economics. Today we will talk about causal relationships between variables. In the previous week we had talked about how to broadly conceptualize development in its sort of various multidimensional nature, and also how to think about poverty as a multidimensional concept within sitting at the core of understanding development. We also had talked about how to measure poverty using data and what are the various issues that researchers faced while measuring poverty, right? Today we will go a step further and discuss more deeply about how to actually use data to statistically establish causal relationships between phenomena. So basically, we want to understand what are the causal relationships between variables, let's say. So, so that sort of is the main focus of our discussion today. How to measure causal relationships between variables, and but what do we mean by causal relationships, and why do we care about measuring and establishing causal relationships? Uh, what do I mean by causal relationships is to establish whether a certain phenomenon or factor affects or causes certain other phenomenon that we might be interested in. So, for example, we would be interested in knowing whether, for example, uh, uh, um, say a lack of savings lead to smaller size of investments in the farms that the farmers work on. Okay, so we want to understand whether the fact that farmers are not able to save, whether that indeed has an effect on their ability to invest. Maybe it does not, even though a priori it might seem that it is indeed, it's sort of understandably true, but it might be that the reason why farmers are not investing in their farm is not because that they're saving less, but because some other market friction. So maybe because it's maybe there are self-control issues, something that we had talked about in the previous class, or something to do with ability to buy fertilizer as and when they want them. Maybe there are, the market is very far away and then there are not roads available. So even if you could somehow magically make them save more, you would still find that they are not still investing a lot. So even if there are things that you a priori may assume to be true, causal relationships between variable may seem very reasonable. Often you go to the ground and you try to establish these relationships using data and econometric methodology. You find out that that's actually not why this particular thing is happening. This lack of investment is happening, let's say, or lack of uh, lack of education outcome is not because that they do not have enough money in their pocket, but because maybe their perception of return to school is not very realistic. So there might be other things that might be driving this specific feature of underdevelopment that you are interested in understanding, but not something that you a priori thought that it would be. So it's really important to sort of test your prior knowledge, your prior beliefs, by actually rigorously collecting data and doing statistical and econometric analysis. So that's why it's important, because often we are surprised by what's happening on the ground, which doesn't match with our preconceived notions of the world. So we really need to understand better about about what's happening in the world, what are the important forces at play in order to that give rise to certain kind of phenomenon that we may be interested in studying, and without understanding them properly, we may not be able to make positive steps. So if we sort of come into this world with this preconceived notion that okay, it's the lack of savings by farmers that's what's causing lack of investment, then if we don't if we don't really test this preconceived notion and right away form policies, we may be misguided. We may spend a lot of money making sure that these guys save more, but then we don't see the outcome, right? So we need to understand first in order to make policies better, in order to change the world. Um, and sort of the second related point is that we need to then understand what kind of interventions actually make things better. So first we need to understand to make a change. Second, we need to then explore, given that we have found out that okay, there are these problems which causally affects this kind of aspect of underdevelopment. We need to then find out what kind of policies can relax these kind of problems or frictions in society, right? So, and one could again have preconceived notions that okay, maybe we should open, we should give them bank accounts if we want to increase the savings of poor people. Okay, maybe that's sort of one policy that you have in mind. Some other people may have some other ideas in mind in terms of how to improve savings. Uh, Now, which of these policy interventions will have the largest effect on increasing savings, if that's what you were after? It may be a priori not clear, and again, we need to sort of try to use data and empirical methods to tease out which policy is more effective relative to other policies that probably would have affected a similar outcome in a similar direction. So we need to more than understanding. So we have to go beyond understanding and see what kind of impacts policies would have on those outcomes of interest. So what we're after is we need to estimate how one particular variable. So in this case, the variable would be the cause. So in the first, the first example of understanding about the world, the cause would be say savings, and we would like to estimate whether that variable has an effect on some outcome. So in this case, the farmer example, the outcome is investment. So we need to understand whether savings, increase in savings increases investment in the farm. Okay, so savings is the cause, outcome is the investment. That's the first example. The second example where we're trying to intervene in terms of a policy to increase savings. In that example, our policy is the cause. Does opening a bank account, that's the cause, increases savings? So then savings becomes outcome variable, right? Because now we are after savings as an outcome through the policy of opening bank accounts. So in the later example, your cause is bank accounts and your outcome variable is savings. Okay, so depending on what specific question you are after, whether you are after a policy question or whether you want to just understand the world in terms of whether X affects Y, your cause variable and outcome variable would be different. But that's the sort of structure, theoretical or conceptual framework in which you have to ask these empirical questions. Okay. So today we will talk about these causal relationships in the form of trying to identify impact of policy. So this sort of second example, kind of examples that we should have in mind. So that's what I mean by impact evaluation. So this the literature on impact evaluation evaluates impact of policies, various kinds of policy interventions. So they are trying to evaluate whether the policy has been effective in reaching the desired goal or not. Okay? The reference for it is the very nice summary paper by Dina Pomeranz in 2017. So I really urge you to read that paper. Okay, so I've already discussed why we should worry about, why we should care about policy impact evaluation. It's really important for any policymaker in the government or any sort of, if you are working in a sort of policy research space, you are trying to advise governments, you need to have a very good sense what kind of policies have what kind of effects on outcomes, and therefore it's really important to use data and econometric methods to get a sense of these numbers, to these estimates of policy impacts, in order to convince in order to sort of give evidence-based guidance to governments about what kind of policies they should be focusing on. And this also it's really important if you're interested in policy. So the way, so I'm going to now introduce a bunch of language jargon, which is going to be critical in laying out the analysis. So the first idea is the idea of a treatment. So what is a treatment? So treatment is basically, you can think about policy as a treatment. Treatment is kind of an intervention in the world, right? In the case of policy impact evaluation, it's literally an intervention, because either the government is intervening in the form of some policy, so raising taxes on cigarettes, or reforming the land laws, or opening bank accounts, what have you. These are literal interventions by the government or the NGOs, what have you. In case of, if you want to understand impact of, say, some say lack of savings on investment, so there having a high saving versus low saving would be, you can think about the high saving as the treatment. For whatever reason, if there are people who are saving a larger share of their income, you can think about that as having kind of a treatment on their behavior. So let's sort of restrict ourselves for the time being on the policy intervention context. So here, think about policy as a treatment. Treatment can be of various kinds. Of course, you can have one discrete intervention, so that its treatment is either 0 or 1. So either you are being treated or you are not being treated. So think about immunization. So suppose the government goes for an immunization drive. So the potential beneficiaries are the kids, and for each of these kids, the intervention is in the form of whether they are getting the immunization or not. So the immunization treatment is it's a 0-1 kind of a treatment. So either you are immunized as a kid or you are not immunized. Okay, so the treatment is kind of just one discrete intervention for a particular person. Or say the government under the Swachh Bharat mission wants to construct toilets for households. So now the units are the households in a village, and each household can either get the toilet or not get the toilet. So again, it's a one discrete intervention for a given household. Okay, so these are examples. Or say banning child labor. So again, the entire country, suppose India, the year it legislated to ban child labor, the entire country got treated with this one intervention in the form of a legislation. So either you have the legislation or you don't. So in the years previous to the legislation, there was no such law, and so the entire country was not treated prior to that year. In the period after that year, the entire country has been treated with this legislation. Okay, so again, it need not be different across different individuals. It can be same, but there could be time dimension also. So here, treatment has a time dimension in the case of, say, this policy of banning child labor. So these are sort of one discrete intervention. You can have a number of discrete interventions. So then there will be multiple treatments within one big sort of treatment umbrella. So for example, suppose you want to find out whether subsidizing fertilizer increases purchase of fertilizer, purchase and usage of fertilizer by the farmers. So in that case, you can have multiple treatments. So for example, one treatment would be you have 10% subsidy. Some farmers get 10% subsidy. There could be another treatment where the government could experiment and give 50% subsidy. In a third treatment, it could be completely free, 100% subsidy, right? You can have these various treatments within this broad treatment of fertilizer subsidization. These are called various treatment arms of this bigger treatment. So you can have multiple treatment arms, which will have various levels of subsidy. And so then it will also be a discrete intervention, but there will be more than one interventions, right? You have sort of multiple kinds of interventions. And finally, you could have a treatment which is a continuous variable, which is not a discrete variable, but a continuous treatment. So for example, you want to find out whether electrification increases growth of firms. Okay, so your cause or treatment here is electrification, and your outcome variable of interest is firms' employment growth or growth in revenue, whatever. So then, your unit could be a district maybe. Suppose you can only observe outcomes at the district level, and you can measure what fraction of villages got electrified. So this fraction is a number between 0 and 1. So 0.3 means 30% of villages in that district are electrified. So then you can trying to find out whether increasing this percentage, whether increasing the share of villages that are electrified increases the growth of all the firms that are in that district. Okay? So suppose you could only, you only know the location, only know whether the firm is located in a particular district or not. You cannot drill down any further. So you can only measure firm growth at the district level, and also for a given district you can't go any further down geographically. And also you can see your electrification data at the district level. So then you are measuring outcomes and as well as the intervention at the district level, and then you are trying to find out this correlation between whether a high fraction of villages that are electrified are also the districts where you have a greater growth of from revenue or employment. So in that case, your treatment is this fraction, which is a continuous variable between 0 and 1. Okay. So what is our objective? Our objective is to estimate the effect of this treatment on some outcome variable. So in the case of this electrification, the outcome variable is the growth in firm employment or from revenue, from performance basically. In the case of subsidy fertilizer, your outcome variable could be usage of fertilizer. Okay, so and to find out whether giving more subsidy, so that's your treatment, leads to greater use of fertilizer. Okay. In the case of immunization, you could have your health outcome of the children as the outcome variable. So the outcome variable is some desired goal that the policy intervention wants to reach, and you want to measure, you want to create a metric using this outcome variable to sort of measure the effectiveness of this intervention or treatment. Okay. Now, in order to estimate the effect of the treatment on the outcome variable, one concept you really have to keep in mind is the idea of a counterfactual. Okay. So whenever you want to estimate an effect of an intervention on outcome, you have to first, basically what you're asking is how much the outcome variable has changed because of this intervention in the form of this treatment. Okay, that's the question you're effectively asking. In order to answer that question, you have to ask what would have happened had the treatment not been in place. If there was no subsidy given to the fertilizer, how much of fertilizer would the farmers have purchased and used? Okay, so that's called a counterfactual. So it's an alternate reality that you have to think about. Unless you have a good answer to that question, to the question of the counterfactual, you cannot answer the question that you're after, which is the effect of the treatment. Okay? If you do not know how much the outcome variable would have changed in absence of the treatment, you cannot answer how much of the outcome variable did change because of the treatment. Okay? So an important critical exercise in impact evaluation, policy evaluation, is to find out what is the right counterfactual world against whom you want to measure the treatment effect. Okay. To sort of make things a little bit concrete, so here is, suppose you are thinking about some outcome variable. So say in this case it is let's say fertilizer usage, or let's say savings. Okay, let's consider savings by rural poor. So you are collecting data, let's say every month you are going to certain set of sample of villagers, and you are collecting data on how much money that they are saving. Okay, and at particular point in time you give them access to bank accounts. Okay, now these guys have been treated with this bank account treatment. So that's the time on which there is a vertical red line, right? So here you see there is a vertical red line. So at this time they got access to bank accounts, and then you continue to measure their total savings, and you see this kind of graph. Now question is, did this intervention of savings account at this point in time had any impact on the total amount of savings made by these people? In order to answer that question, you would have to form a counterfactual about if there was no savings bank account given out at this point in time, how would this variable have moved? And if you're by some method you try to say that, okay, so if this is what the counterfactual is, in the sense that this is what the savings would have been in absence of any bank account access to these people, then my estimated impact after say 3 months is this green vertical line. So this gap between the blue and the yellow at month 3 after the treatment gives you the effect of the treatment after 3 months. Okay, so that's the idea. So then this requires, in order to estimate this vertical gap, you need to first have an understanding of how to get this counterfactual. Okay, so that's the idea. So in order to help form a good counterfactual, what you need is a population group which is similar to the group that are getting treated, similar to the group that's getting treated, but this other group is not getting the treatment. So in terms of various characteristics of the population, the group that is getting treated, which we refer to as the treatment group, and this other group that we need to consider, which we'll refer to as the control group, they are similar in terms of their individual characteristics or various other features. So they're comparable group, but only the treatment group is getting treatment and the control group is not getting anything. Okay, so this group will help us form some kind of a counterfactual. Okay, so it's important to have a control group when you are having this kind of discrete treatment on a section of the population. And if you want to find out whether this kind of treatment had any effect on that population, that treatment group, you need to compare their outcomes against a comparable group which is not getting the treatment, which we'll refer to as the control group. So one way to measure policy impact would be to look at the outcomes after 3 months in the treatment group, say after this bank account intervention that happened. We measure the outcome of those guys that got treated after 3 months. We also measure the outcome of a comparable group that didn't get the bank accounts. And then we look at the difference between the outcomes of the treatment and the control groups. The assumption being, so here comes assumption, the assumption being the treatment group would have behaved similarly as the control group in the months after the treatment, in absence of the treatment. So suppose the treatment hadn't happened on the treatment group, then the treatment group would have behaved similarly to what the control group had behaved, right? Because we don't see in reality how the treatment group would have behaved in absence of the treatment, right? That's a counterfactual that we are imagining. And the assumption is that the treatment group would have behaved same as what the control group have behaved, right? Why we are making this assumption? We are making this assumption because the control group to begin with was similar in its features as the treatment group. Okay? That's why that allows us to make that assumption. Now, that sort of very crudely speaking, that one way to form counterfactual, and that will sort of help us measure the policy impact. However, we have to worry about certain issues here if we want to sort of blindly form treatment and control and measure their differences in outcomes. Because if we do not pay serious attention to some of the concepts that are laid down here, we may lead to incorrect. This may lead to incorrect conclusions. So what we have to worry about is what we call endogenous treatment. What do I mean by endogenous treatment? I mean that the treatment is not randomly assigned to a bunch of people. There is some method through which treatment was assigned. If that's the case, then it might possible that the assignment of treatment is probably correlated with certain features of either the context or of the individuals who are getting treated. And if that's the case, then this method that I've laid out here to sort of just measure policy impact by the difference of outcome in treatment and control will lead to some biased estimate, meaning that we will either overestimate the effect of the treatment or underestimate the effect of the treatment. If the treatment is the assignment of the treatment to individuals is correlated with some features of the individuals, or it is correlated with some context, overall context. So let me sort of parse this out. So the first kind of bias is what is referred to as selection bias. So what is selection bias? So selection bias is something where the group, the treatment group, the people who are getting treated, if they suppose self-select into the treatment. Okay, so suppose let's say that you want to see whether giving bank account access to farmers or poor people increases their savings, and say what you do is, suppose you open a bank branch, you sort of convince the local state, the state government to open bank branches in the previously unbanked area. So now there are bank branches opening, and then only the people who self-select, who's into opening a bank account, meaning those who on their own volition sort of walk to the bank branch and open an account, only those guys will be the treated guys, right? Because only them, the guys who walk up to the branch and open a bank account will have a bank account, so they will be the treatment group. So these guys are self-selecting into treatment. They are sort of by their own choice entering the treatment group, so to speak. Now, it is understandable that the people who choose to open a bank account would be very different from people who choose not to open a bank account, right? The people who choose to open a bank account, maybe they are much more financially literate. Maybe they are much more motivated guys who really want to save money, right? Maybe this group are particularly interested in investment, and they're really looking for opportunities to save. So these people are characteristically very different from the rest of the population, and these are the ones who are self-selecting into opening a bank account. Now, if that's the case, then you are getting a very different kind of sample into the treatment group compared to the people who are in the control group, who are choosing not to open a bank account. So when you measure their outcome variable, meaning how much savings that they have done group level, after this bank account opening event happens, then the estimated effect may be much larger than the true effect of opening a bank account, because the people who are self-selecting into this treatment group, they are the super motivated, they are the people with better ideas of investment. These are the guys who want to really open a bank account. So what you may end up finding is that bank account opening may have a really large effect, but some of this estimated large effect may be driven by the fact that these people in the treatment group are very different than the rest of the population. So it's not really then, not the full effect is not driven by the fact that there is a bank, that these guys have a bank account and these guys don't. Some of the effect is driven by their sort of self motivation, their better ideas about why to invest money, etc. Right? And you should, in order to find out the true effect of bank account opening, you should be able to then, you have to throw these other effects from the estimated effect. You have to throw these other factors out in order to get the true effect of opening a bank account. And you can't do that because often these things are unobservable, right? How do you measure? How do you know how or why, what factors or what features of an individual is pushing them to open some bank account than others? Often there is no data for these sort of internal factors. And therefore, these unobservable characteristics may drive part of the estimated effect, which would be wrong to estimate. So that's sort of one sources of bias in the estimate. The second source of bias is omitted variable. So that's about the context. That's not about the individuals choosing to enter the treatment group, but it's about the fact that when the treatment is happening, there might be other things that are also happening that are affecting the treatment group differently than the control group. Maybe when this bank branch is getting opened, some local firms that are selling fertilizer, they have come to know that okay, there's this new bank branch coming up in this village, so they know that there might be people saving up money to buy fertilizer. Why not open some new shops to sell fertilizer there? So now part of this savings effect of opening savings account on, say, investment, you see, not because of savings account per se, but also because there are these other stuff that are happening with the treatment. And so for example, this new investment opportunities arriving in the village along with the bank branch, like these fertilizer shops, okay, or new sort of luxury good items may start being sold there, because these firms know that there will be a demand for this, because there people will have money saved in their bank account, so they can afford later in a few months they'll be able to afford more expensive stuff. So then if along with the treatment there are these other stuff that start happening which affects the treatment group differently than the control group, and these cases it will do, people who got the treatment, those who got the bank account will be able to save more money, and hence will be able to afford to buy better investment opportunities or more luxury items. Then part of the effect would be driven by these other factors. So this is what is called omitted variable bias. So you have to basically you should have accounted for arrival of these investment opportunities or new shops opening in the village, but you didn't control for these variables when you estimated this effect, and part of what you're estimating is also capturing this other effect of this other stuff that are happening at the same time when treatment happens, right? So these are the complications that you have to keep in mind. So the first is selection problem, individuals choosing to be in the treatment group versus in the control group. That's selection. And the second is there might be other stuff that are happening along with treatment which might also affect the treatment group differently and hence get captured in the estimated effect, which would be as bias. So that's the omitted variable bias. So these two are the sort of main worries when you are generally trying to estimate effect of policy. Let me introduce two concepts before moving to sort of various methods to sort of address these issues of endogeneity of treatment. So the first concept is internal validity. So if you basically ensure that these two biases do not occur during your estimation method, then you are more convinced that whatever estimated effect that you find is indeed close to what the true effect is. right? Because you are trying to measure something about reality, to what extent these opening bank accounts change the savings and investment behavior of the villagers, and you are following some method, and if you can ensure that in your estimation method you can get rid of selection bias and omitted variable bias, then your estimate would be close to the truth. So then what we'll say is, in the sample where in the sample of villages where the bank branches did open up, so where you could have this treatment and control group of people with bank accounts and people without bank accounts, the estimate will be internally valid. Internally valid meaning it's valid within the pool of control and treatment group. So within the pool of population that constitute the treatment and the control group, the treatment effect, the estimated treatment effect is the true effect. Okay, so it's internally valid to the population on which treatment is getting assigned. This is separate from the concept of external validity. External validity is, does your estimated effect generalize to a larger relevant population that this pool of treatment and control is supposed to represent? So suppose the bigger question that you are after is, if I open bank branches in rural India, how much it would improve savings and investment by the farmers from rural India. Okay, so your relevant population is rural India, but you are estimating using, say, opening of branch account or opening of bank branches in only a smaller set of villages. That your internal sample, and if you can get rid of these two biases, then with more confidence that your estimate is internally valid for that sample of villages that constitute your data. But then you're asking a bigger question, which is, does that estimate generalize to the entire rural India as well? Okay, that my sample is supposed to represent. So my sample is supposed to represent the entire rural India. I want to get an answer for the entire rural India because I want to convince maybe I want to talk to the government and advise the government about expansion of rural bank branches. But to do that, I can't start opening bank branches in the all of India, because that would be like having the entire policy itself. So maybe I try it in set of few villages and I get an estimate which is internally valid. But then I have to convince that this estimate is true for the rural India, which is what the government cares about. The government doesn't care about my small sample. So that's the idea of external validity. To what extent does your estimated impact of policy generalize to the entire population, relevant population, that the sample of treatment plus control is supposed to represent. Okay, so these are the two different concepts, and the most of the talk today will be about internal validity, because that sort of is what the researchers has primarily been focused on, though now there are more and more concerned with external validity of those internally valid estimates. But for the bulk of the talk, I'll be talking about internally valid estimates, how to arrive at internally valid estimates. Okay, so let me talk about some methods. Okay. So the first method that I'll talk about is randomized control trials. So this is the method that was first adopted in the medical science literature to estimate the effect of medicines. So they want to find out. Medical researchers wanted to find out efficacies of drugs, which is why they started using this method, randomized control trials, and then people like Abhijit Banerjee, Esther Duflo, and others They sort of popularized this method in the context of development economics by adopting and applying this method to understand impact of policies, and that sort of gave them the Nobel Prize this year. So let's start with that method, because that's sort of, in some sense it's the most straightforward method that one could start with. So what are randomized control trials? So a bit of notation. So suppose your sample population is this n people, so they constitute the total treatment plus control, right? So that's the entire population that you start to work with. Suppose each individual unit, this unit could be an individual person, it could be an household, right? So if suppose it's immunization treatment, so then it's an individual kid. If it's a toilet construction treatment, then it's a household. If it's electrification, then it's either a village or a fraction of villages in a district. So these units will be districts. So depending on context, these units, the meaning of these units will vary. Anyways, so these are the relevant units. So let's think about individuals first. So let's think about immunization, let's say, or bank accounts given to rural poor. So these are the n treatment plus control villagers. And then you are assigning some treatment to some of them. Okay. So this treatment could be some various kinds of things. Here we are talking about one discrete kind of treatment, just for simplicity. So treatment. So TI is the treatment status of individual I. Treatment TI equal to 0 means that the individual did not receive the treatment. So the individual did not open the bank account, and TI equals to 1 means they opened the individual opened the bank account. Okay, so it can be either 0 or 1. You have some outcome of interest in mind that you want to measure, so that's your metric to compute the effectiveness of the treatment. So suppose this is your savings of individual I, okay, and savings of individual I depends on the treatment, okay, treatment status of the individual. So savings potentially, so savings by individual I depends on whether individual I has a bank account or not, whether it's treated or not. Okay. What we would like to do, we would like to find out for each individual what is the difference between yi1 and yi0. First, that's the first point. What is yi1 minus yi0? This is the effect of opening a bank account on savings of individual I. So yi0 is how much would individual I save if she doesn't have a bank account, and yi1 is her savings when that same individual has a bank account. Okay. Then you look at the average. So the average across all individuals, all n individuals, this difference gives you the average treatment effect. Okay, in short, the ATE. So that's what we are after. We want to find out whether on average this treatment of opening a bank account or immunization had an effect on outcome variable of interest. So savings or infection, etc. Okay, so that's what we are after. The problem is, of course, you have to think about counterfactual. Why? Because for a given I, we either see what is the outcome, because for a given individual, either the person has a bank account or not. So whatever savings information that you can collect for the individual, either it refers to yi1 or yi0, right? So in reality you only observe yi1 or yi0. Either if the person has bank account, then you observe yi1 for that individual, or if the person doesn't have the bank account, then you observe yi0 for that individual. You do not observe both for any given individual. Okay, so that's the problem. So then the question is, how much the person who has the bank account would have saved had he not had the bank account. Okay, so that's sort of is the kind of question you have to ask in order to get the counterfactual for the people who have the bank account. And similarly, you have to ask for people who don't have the bank account how much that those individuals would have saved had they had access to a bank account. Now, what randomized control trial does is that it randomizes access to treatment. It randomizes the treatment across this n people. So it randomly assigns the treatment to a subset of the pool of the sample. So if the meaning is so in the banking example, it randomly opens bank accounts for some individuals in the village, and for the other individuals it doesn't open a bank account. So it's kind of completely determined by the researcher who are studying this question. There is no, so that reduces self-selection, right? Then there is no point in villagers choosing themselves to be inside the treatment group or inside the control group. There is no choice on the part of the villagers. It's the researchers or the government. They are the people, the organization who are deciding this treatment. They are completely determining randomly who gets the treatment and who doesn't get the treatment. Randomly, researchers give some kids the, 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 the immunization, and the other kids they don't give the immunization, or some random subsample of the pool they give access to bank accounts, then the rest they don't, right? So it's done randomly, so through some lottery. Why does that help? Well, let's go through this tiny bit of calculation. So expectation of yi1 minus yi0 is nothing but expectation of yi1 minus expectation of yi0, right? It's additively separable. Why? Because expectation is a linear operator. It operates, you can separate the individual terms inside an expectation. So you can take the expectation inside each one of these. Okay, so that you can do anyways. For that you don't need randomization. What you need randomization is the second step. So what is the first term? The first term is what is the expected value, what is the average value of say the savings rate for all the individuals, for if all the individuals get treated, the entire n people. If all of them are treated, if all of them have bank accounts, what is the average savings? That object you don't know, because some of them have bank accounts, some of them don't. But if the people who have bank accounts are a random sample, then this average is same as the average of the people who indeed have the bank account. So what is the difference between this term and this term? In the first term, we are including everybody. For all I, you are taking the expectation, right, from 1 to n. But here, you are conditioning on the people who indeed have the bank account. Okay. Remember, in this case, not everybody has the bank account. Some are in the treatment group, some are in the control group. But if treatment assignment is random, then the average value of outcome for the treated group is same as the average value of the outcome of the entire sample population if they were to be treated, right? So that's the counterfactual. So now this is the observed. This is what we observe. This is the observed metric. This we can compute. We can compute the average value of savings by the people who have bank accounts. But if the bank account assignment was random, this is same as the average value of savings if everybody was given a bank account. Similarly, the average value of the savings if nobody had bank account is same as the average value of the savings of only those people who don't have bank account, meaning the control group. So A is the mean of the outcome in the treatment group and B is the mean of the outcome in the control group. These two we can compute, and because treatment and control was decided randomly, A and B basically captures these two terms, and hence we can compute the average treatment effect. Okay, so that's the idea. The randomization helps us compute counterfactual by getting rid of the selection bias. Okay, it helps us because the people who are in the treatment group are on average identical to the people who are control group, right? That's why it's, that's what randomization gives you. So randomization gives you that probabilistically they will be identical, and therefore the average of the savings in the treatment group is same as the average of the savings had everybody had been treated, right? Because the treatment group is effectively identical to control group, right? So their average will be same as the average of the population. Okay. So that effectively, solves the problem of finding out counterfactual and computing average treatment effect. The only issue is that this can only be done for averages. If you only want to find out average of the treatment effect, but suppose you want to you are worried that maybe average is affected by some extreme values, so you are interested in finding the median, which is not sensitive to extreme values. Then you can't do it. You can't find out the median of the treatment effect using this method, because you can't do this decomposition. From here, you can't go here. Median of y1 minus y0 is not median of y1 minus median of y0. Okay, generally speaking. So you can only do it for averages. Moreover, if treatments are highly heterogeneous, then that might be an issue, because then maybe for some individual eye the treatment really affects a lot the savings rate. Maybe some individuals, if they got savings bank accounts, they will be able to save really a lot of money. If there are people like that in this n sample, then your estimated average treatment effect will depend a lot on whether that individual is actually in the treatment group or in the control group. Okay, if the individual who would have had a very high treatment effect, if that person by chance falls in the control group because they're randomly getting assigned, then the estimated treatment effect will be much smaller than had the person been inside the treatment group. So if the effects are very heterogeneous across individuals, which is sometimes the case, then there might be issues with reliability of the estimated effect using RCTs. And finally, you have to worry about external validity. So you have to say, okay, you are doing this randomized controlled trial on this n people. Are these n people representative of the bigger population that on which you are supposed to sort of scale up the policy? So in case of bank accounts, maybe you are going into some set of villages in Rajasthan and doing this experiment, but does it generalize to all of rural India? Okay, and that is a very tricky question, because these villages where you are doing this randomized control trials are themselves not randomly selected. You don't select these villages randomly from all of India. You select those villages based on administrative ease, whether you have NGO network who can implement the survey there, whether the government agrees to let researchers do experiments there. All of these conditions will have to be met. So this set of villages or this set of people on which you are experimenting are not necessarily randomly selected from the entire population. So there might be issues with external validity in that case. So in the next part of the video, I'll talk about an example of RCT and move to